We should be experts at this point on how to summarize and display categorical variables, and now we would like to move on to the same for quantitative variables. So just as a reminder, quantitative data is numbers that act as numbers, so we're dealing with, actual numerical data. And in order to display this graphically, we'll use a dot plot, a stem plot, or a histogram. If we want to display this numerically, typically that is with summary or descriptive statistics. A dot plot is one way for us to display our numerical or quantitative data. And the advantage of a dot plot is that we can see it kind of looks like it would be a bar chart. So we can treat it sort of in the same way as, our bar, or what we will learn is actually called a histogram when dealing with quantitative data. So that's the advantage. The disadvantage here is obviously it's sort of a pain in the butt to make by hand. And if we did make it by hand, it's very easy to not keep the same amount of space in between each dot, which can make our data appear not quite as, great as it should. A stem plot is not something I will ask you to make, but you will be asked to make decisions about data given to you in a stem plot. And again, it's similar to a histogram, so if you turn your head to the side, you can sort of think of this again as a histogram turned to the side, or if you turn your head to the side, just a normal looking histogram. And what's important to understand about a stem plot is essentially just how to read it. First of all, you should have an answer key somewhere, and that answer key tells you what your data is that you're looking at. So the stem is like the stem of a plant, and each leaf connects to that stem. So this is 2, 1. My key says that that number is 21. 3, 5 tells me that number is 35. Here I've got 40, 4, 0, and 43, 4, 3, and 49. So this stem of 4 had 3 leaves on it. And I can continue 51, 54, 57, 58, 58, 64, etc. So that is how we read that. Again, you should be looking for the key. You might also see a split stem plot, which notice is similar. The reason we might choose a split stem plot instead of just a regular stem and leaf plot is if you have a lot of data, I would put the leaves of 0 to 4 on my first stem, and on the second, 5 through 9. It's just a way to make it so that I can really see the distribution of data, because if I had all of this data, instead I would just have 3 leaves, 3 stems, 2, 3, and 4, and then a very, very short leaf here, and then all of this would be together as one, and all of this would be together as one. So using a split stem plot on this one does tell us more about the data. If we want to compare two distributions, which we'll look at next week, you can use a back-to-back stem plot. And again, that just uses the same stem for 2 different distributions. So here I'm looking at pulse rate before exercise, which would be 50, 52, 53, etc. would be my lowest ones. And after exercise would be 59, 62, 64 would be my lowest ones. So it's just another way to display data. What you'll see most often in this class is a histogram. And a histogram divides values into bins. And essentially what we're looking at here is, notice that there are no spaces, whereas when we talked about the bar chart a little while ago, there were definitely spaces. The reason there are no spaces here is because the bottom, the horizontal axis, is essentially a number line. And in a number line, we're not going to have any gaps because it's just continuous. And what we want to do is we want to have our data into bins of equal width, and notice that the height would be the frequency of each of those. So if I had a frequency table where the magnitude of 4, 4.5, 5, etc., it looks like the number for 4 is really super small. Let's just say 3. 4.5, it looks like there's a little bit of a bar there. 5 to 5.5, I would say looks, say like 10, etc. So that would be the data that is being displayed in your histogram. So a histogram typically has a frequency table associated with it. And again, the bars should be touching, and we try to divide the min through the max up into just equal ranges called bins.